I'm Seb, one of the 3 volunteers in the salary survey team, along with Jonathan and Andrew. There's an important update we need to give on the salary calculator tool that we launched onto grux.org. When we were updating the salary calculator with new data for 2021, we found an error in the way the 2020 calculator tool was making its calculations and presenting results. The error meant it incorrectly gave lower predicted salaries for high-paying geographical regions and higher predicted salaries to low-paying geographical regions, and this effect was greater for people further along in their career. This video is to explain a bit more about the error and its impact. Andrew's going to talk through how the calculator works and present some example discrepancies.
Hi, I'm Andrew Mengerogel, and I'm part of the salary survey team along with Seb and Jonathan. My goal here is to explain as clearly as I can what was the error in the salary calculator and what the impact was. So what you see here, this is a formula for solving log linear regression. That was the model that we calculated with in the analysis of the salary survey. And if we wanted to find out what a person's predicted salary would be, if we solve this model, we would learn that. So when we calculated the model, that gave us the numbers for the alpha and these betas here. And if you wanted to complete the formula, a person would enter their values for their position level, their years of experience in games user research, their age, education, and the region that they lived in. Along with a constant, again, this is given by the model, then that is going to give you a predicted log salary. Now, I do want to emphasize here that even though I'm describing this formula in math terms, should be thought of as more of a conceptual formula than strictly a mathematical formula. So I do also want to point out that this is going to give us a log salary, and that is a wrinkle in this equation. And that's because when we finally, solve this formula, the value that we get out of this is going to be a number like 10 or 11 point something, not an interpretable annual salary. And why is this? That's because before we even built the model, we had to deal with the fact that we were trying to predict financial income data. And income data are not normally distributed. And a lot of statistical analyses, including regression, do depend on an assumption that the data that are included in are normally distributed. So before we conducted the analysis, we had to transform those salary data. So just to give an example here from this methods article, salary income typically looks something like this. There's a lot of people with lower incomes and then many less people in these higher tiers. If we do the transformation, a logarithmic transformation, then the data start to have this normal distribution. I do want to point out I'm just drawing this from a methods article and not from not showing you our raw data because I want to protect those data and only show the results in aggregate. Okay, so that is a wrinkle that we have to contend with, but log linear regression also has some benefits. And here's one of the features is we can take any one of these coefficients, these predictors, and if we do this formula to them, what that will do is it'll tell us the percentage change in salary for one level of this variable versus another while we're holding the other predictors constant. What does that mean? Here's an example. If we take education and a bachelor's degree, if you're holding a bachelor's degree, that is the point of reference. That person makes 100%. But if another person there who've got a master's degree, they're making 12% more than a person with a bachelor's degree, according to the model. And that's when controlling for region, age, years of experience with games user research and position level. And then beyond the master's, if a person has a doctorate, they're making 20% more than the person with a bachelor's. And if this looks familiar, that's because this was actually one of the slides from or one of the charts from our presentation at the 2020 Games User Research Summit. So I just want to emphasize here that this is coming from the model. This is reporting what was in the model. And all of this information was correct. What we've said that there is an error with doesn't have anything to do with this. You can be confident in this analysis, and we stand beside it. What I do want to talk to with the error is in this calculator, and this is what we made available and drew everyone's attention to at the end of the presentation. And what this does is, again, it's inviting each person to input their values on these different predictors, and then it's going to run the calculation. What the calculator was programmed to do was to create the percentage change based on each of these, add them together for a sum percentage change. And then this constant is still here. That's going to be around $61,000. So we add the $61,000, and then you take the percentage change times the 61,000 to get the monetary value of that percentage change. And that's going to result in a salary, not the log salary, the actual salary. Unfortunately, this is not the correct way to do it. Instead, when we go through this process of changing this number from the raw output of the formula, when we change it into a percentage change, that now means that the calculator should have been multiplying those percentage change together for a product, not a sum. And then the rest of it is solved in the same way. So in short, we can say the calculator added when it should have multiplied. So the impact of this error is that when folks predicted salaries should have been changing on a multiplicative basis, they were actually only being changed on an additive basis. And that will become clear in the next few slides. What I want to show you is 3 prototypical user researchers, someone at an entry level, someone more mid-level with a little bit more education, and then a very senior veteran PhD holder. And we'll see how that error in the calculator affected the predictions that the calculator was making. So here, quick tutorial. The y-axis is predicted annual salary in US dollars. Across the bottom, these are just the different regions. They're not in any particular order. These are all categorical values. And then up here, this is just describing what kind of person we're looking at. This is someone with a bachelor's degree. They're in their early 20s. They've been in games user research for a year, and they're at a junior position. The orange will give you what the original calculator predicted, and the blue gives what the corrected calculation would be. And really, it's hard to see the orange because the blue is covering up the orange. Maybe you can see some here, and that's because they are so close. In fact, the average discrepancy for this prototypical user researcher is only $300. Moving along to the more mid-level person, this is someone with a master's degree. They're in their late 20s, been doing games user research for 3 years, and they're a mid-weight staff researcher. Now we can start to see that there is a difference between what the original calculator was giving and the corrected. And on average across all of these regions, that difference was around 8,100 US dollars. Another thing I want to point out here is that the direction of the miscalculation is different, or the direction of the discrepancy. So in the West Coast of the United States, these are the 2 highest paying regions, Pacific Northwest and California. The result of the calculation originally was lower than what the model should have been calculating. It's too low. In these other regions in the world, in Canada, Europe, the United Kingdom, the result of the calculator was higher than what the model was actually predicting. And then for this last person, the more veteran person, the person holding a doctorate, early 40s, 10 years of games user research experience, they're a manager or an executive. We're seeing a much even bigger discrepancy here on average across the regions, $22,000 USD. And that trend among the regions, we see that these two regions on the west coast of the United States, the calculator was giving values that are too low, and in these other regions, the values were too high from the calculator. So when we look for an overall pattern here, just looking at these three prototypes side by side, we can see a couple of things. Orange, the calculator as it originally was programmed, was giving predicted salaries that were too narrow, meaning that the distance between the blue dots is much greater than the distance between the orange dots. And that's that part of, the orange dots are based on this additive formula, and the blue dots are based on this multiplicative formula. Another thing that I observe is that as a person gets more advanced in their career, the effect of the error becomes much greater.
We took the calculator offline as soon as we suspected an error. At this point in time, we've chosen not to fix and republish last year's calculator tool. Instead, we'll work on the newest data. The analyses we presented in the recorded presentation and in the infographic remain accurate. They were calculated independently of the salary calculator tool. We understand that this data is really valuable and really important, and all three of us profoundly apologise for not delivering on our promise of the salary calculator. We certainly don't take the responsibility of the salary survey lightly. Thank you for listening. We welcome discussion of this error in the Grux Discord, where you'll find a channel dedicated to the salary survey and an ability to ask us any questions. Thanks.